All right, let's talk about the test. Now, as always, I'm going to show you the test, but I'm not going to show it on the camera so you can't zoom in and see every question. All right, so off camera, here's the test. The whole front side, as you can see, is multiple choice. All right, and the back side has a chart on it. And don't be surprised. I mean, I'm not worried that you're seeing that one because even if you know which one that one is, you may not get the same one. You're not going to have necessarily the same exact test. Oh, hit that light for me so you can see. On. No, both of them on. There you go. So the whole front side is multiple choice. The back side's got a chart. It's got 2 short answer questions and a few more multiple choice and another chart that I want to talk about, all of which I'm going to go over right now. But I'm going to start with something that will help to summarize what we've been doing. And that will be the answer to this question right here. Okay? Let me read that question, and then I'm going to read you a bad answer. Now, I want you to pay attention to both. The question says, explain how metallic character changes from top to bottom within a group, and why. Now, a question like that could be answered like this. I've seen an answer like this 100 times, and always people are surprised they're losing points on it. They'll say, in keeping with restating the question, metallic character changes from top to bottom within a group because of the atomic size and the shielding effect. And they'll be surprised if they get points off for that. Let me say it again. But I did everything right. I restated the question. I looked at my notes, and both of those things are there, atomic size and shielding effect. I mentioned both of those. So why am I not getting full credit? Why am I only getting less than half credit? Let me tell you why. Let's read the answer again. Here's what they said. Metallic character changes from top to bottom within a group because of atomic size and the shielding effect. What's wrong with that answer? Well, one thing that's wrong. They didn't say, well, actually, they did. They just didn't explain it very well. First of all, there's another mistake about it. They did explain why. They just didn't explain it very well. Just specifically what was wrong with that boat.
They didn't say how.
They didn't say how.
Like it increases.
It increases. It didn't say if it increased or decreased. That's a biggie. All right. It said. I told you to explain how metallic character changes, and they said metallic character changes because of. It never said how. Never said if it increased. Never said if it decreased. So, well, and what's the about as far as not explaining it very well? What else did they not do by saying that because of atomic size and the octet rule? What do you think?
They didn't say what the atomic size had to do with it.
Exactly. And I said octet. I meant shielding effect. They didn't say what the atomic size does. The atomic size is getting bigger. They should have said that. And they should have explained the shielding effect, too. Now, let me tell you what a good answer would sound like. Listen carefully to this. You can watch it again online if you wanted to. So, Karen, look at what are you possibly doing? That's more important than me telling you exactly what the answer is. Look at, listen. No, you're doing this. What is it? What are you playing with? What are you playing with?
Nothing. But
Seriously? You people, I think you're like so used to playing with your cell phones that half of you guys just look at your crotch all the time. I mean, you have to have something there. It's like, it's amazing. I know, but you gotta watch. You gotta pay attention. All right. Now, here is a good answer. Okay? Here's how I would have answered it. Metallic character is the tendency for an atom to lose electrons. And as you go down a group from top to bottom, atoms will lose electrons more easily because of the atomic size increasing, so the electrons are further away, and the shielding effect, which is the decrease in the outer shell electron attraction because of the interference of the inner shell. Now, I did that all at once. That would be a run-on sentence. But you understand what I'm saying. Now, off the top of my head, I redefined what metallic character is, because you kind of need to know what it means. I also told you whether it increased or decreased. And then I explained what it did in terms of atomic size and the shielding effect. Okay. Now, let's get, you can turn that light off again now. That will be, you're going to see 2 of those kind of questions on the test, guaranteed, 2. And they should both be answered with that kind of detail. Now, let's go over the multiple choice, because that, as you saw, is a whole front page and part of the second page. And I purposely chose representative questions on here. And one of the big things you're going to have to know, besides the actual notes and memorization stuff, and there is some memorization involved here. I'll talk about that as we go along. Besides that, you're going to have to know how to choose between several choices of elements in the periodic table. Who would have the highest or lowest or best or worst or whatever. So let's do that. Let's look at these 4 guys and where they are in the periodic table, and then see how I would answer these questions. You see a lot of questions like that. All right, let's look at the periodic table. All right, let's. Let's look at the periodic table. And then see how I would answer these questions. You see a lot of questions like that. All right, let's look at the periodic table. All right, let's look at the periodic table. All right, let's look at the periodic table. All right, let's. Let's look at the periodic table. All right, let's. Let's highlight each one of them. I would say, let's see what we got here. Cesium, right? What else?
Fluorine.
Was it fluorine?
Fluorine. Yeah.
Fluorine, what else? Germanium?
CS.
Yeah.
CaCS.
Germanium and
Um,
Ca. Is that right? Those guys there? You know, I can't really see that color very well. Let's try a different color. Let's try red here. Okay, so cesium, calcium, germanium, and fluorine. Is that right? Yeah, I can see those pretty bad. Well, all right. Who can I eliminate for any of the extreme questions? Who am I going to eliminate? Ca and germanium, because we know that everything changes like this. Everybody agree? Okay. So I'm going to eliminate those guys, but not from every question, but just from the questions that ask about who's the best, who's the worst, who's the highest, who's the lowest. Okay? Let's go back and see what the first question asks us. Who has the highest electronegativity? Well, that, again, you can't answer that without first knowing what electronegativity is. So you got to know what that is. It means the attraction for electrons. Now, when I look at this guy, I ask myself, who of those four, for the three reasons that I told you, the three things that this chapter kind of boils down to, would have the highest attraction for electrons? What do you think? You all agree it's fluorine? Right? And here's the three reasons. I think I told you this a couple of times. Atomic size will help you predict almost anything. Shielding effect and octet rule. Those are the three biggies. If you can apply those, instead of memorizing 16 different things for 4 trends, you can pretty much know those 3 things and apply them to every trend. Because I know fluorine will be the smallest atom, and therefore electrons are closest to the nucleus. He's closest to an octet, and for all of those reasons is holding on to his electrons the best. So he'll have the highest electronegativity. All right? Okay. Let's look at the next one. Whoops. Strongest attraction for electrons. I don't need to restate that. It's the exact same rationale, and it will be the exact same answer. Fluorine, right? Okay. Attraction for electrons is a definition of electronegativity. Okay, only 2 electrons in the p sublevel. Now, for this guy, of the choices I have here, I can choose one of the non-extremes. I'm going to look where the p sublevel fills. That's this area right here. Everybody agree? Second one over would have to be one of these guys. And, of course, the only one of the choices is germanium, so the answer is germanium, right? Now, how about largest atomic radius? That's really easy. The guy furthest down and to the left, which, of course, is cesium, right? I think atomic radius is the easiest one, not only because it's the first one we did, but because we apply it to all the other ones, right? Now, how about the lowest ionization energy? That's a tougher one. Not so easy. I have to think about that one. I have to ask myself the question. Do you feel lucky? Well, punk, do you? That's, what is that? Come on. Nobody. All right. Dirty Harry, yeah, right. Do you feel lucky? Who said that? Ben, good job. All right, should give you bonus points for that. Ionization energy is a tougher question because it's not a simple one like size. I just look at that chart over there, or I just look at my pumpkins tomorrow when you're taking the test. Look at the pumpkins. Look at Rebecca's hair, and you can't go wrong because it tells you what the size is going to do, right? But if I ask you about ionization energy, it's not so easy. I've got to think about it. I have to know ionization energy means the amount of energy it takes to remove an electron. Then I have to apply it. Lowest ionization energy. What does that mean? Well, it's got to be easiest to remove an electron from. Then I have to apply it to my atomic size. It's going to be easiest to remove an electron from cesium because he's the furthest down and to the left. He's nowhere near having an octet, and he's the biggest, so electrons are furthest away from the nucleus. Got it? All right, next. Best metal. For the exact same reason, the best metal will be cesium. Exactly what you apply everything I just said, because what does a metal do? A metal loses electrons. Best nonmetal. The exact opposite reasoning, it's going to be fluorine. He wants to gain electrons. He's the smallest atom, closest to the nucleus. Okay? Tends to gain electrons when forming a compound. Again, fluorine. You could say that germanium might want to do that too, but really he's a metalloid. You can kind of go either way. All right, so fluorine is your best bet on that one. Next one. Has 2 electrons in the outer energy. Now I'm not limited to those guys that I eliminated. I can choose anybody of those 4. And I said 2 in the outer energy level as opposed to 2 in the P. I bet some people for the 2 in the P put down calcium. Calcium's the answer for this guy. He's got 2 in his outer energy level. Got it? All right, how about the next one?
Wait.
What? That did ask you about energy level, right? That was this one, number 9. Number 10 has only one electron in the s sublevel. Again, I just look where the s fills. This is where the d fills. P, F. The s sublevel fills here. The only guy who's in the first one of those would be cesium. And was that one of my questions on there? Cesium. Was that one of my funny questions? No. Like, what do you do when you I don't know. I tried to think of something like that. No wonder it wasn't on there. You cesium. What do you do if somebody runs away? You cesium. Yeah, maybe not. It could have been on there. It could have been, but it wasn't. Has electrons at the 6th energy level. Okay, 6th energy level. You'll know that because he's in 1, 2, 3, 4, the 6th row, the 6th period. That's what those are called. So that would be cesium. Okay, and all the stuff that I've already been using from last chapter is fair game in this one too, people. All right, like for example. You should all know how, I've been doing this in some of the worksheets. If I say something ends in 5p3, you should know what element that is. It would be the 5th row down. P block, 3rd one over, antimony, right? You have to be able to do all that stuff. You know what else you have to know how to do? You have to know how to you have all the stuff to memorize. There's a lot to study for this test. What are these guys called? The alkali metals. These guys here? Alkaline earth metals. These guys in here? The transition elements. These guys that border this line. Metalloids. And these guys here, halogens and noble gases. Now, if any or all of those were surprising that people were yelling those names out, it means you have studying to do. All right? It's not enough to just understand those 4 trends. Those 4 trends are a big part of it. You're going to have to explain 1 or 2 of them. You're going to have to do a chart. I'm going to do a chart in a minute. You're going to have to also have multiple choice questions on it. There's a lot of stuff on the trends. However, there's also a lot of memorization stuff too. You have to know Mendeleev, the guy's name, all the stuff that we learned. What's a period? What's a group? What does it mean? There are names for a period or group. It's a series, which is a group is a family, right? You got to know this stuff. All right. So you forgot all that. That's why I reminded you. Now, how many more left here? Has an outer configuration, ends in 4p2. I just did one like that. And who would that be? 4p2. 1, 2, 3, 4th row down. P blocks. That went over germanium. Got it? Now, let's go back to this one here. This is if there's any kind of an actual problem on it that's not just multiple choice matching. It'll be this. You got to actually give me a number. You actually have to use a number in these. All right. Let's look at rubidium and bismuth on the periodic table here. Here's rubidium. Right here, and here's bismuth, which is none of your business, but right over there. Okay? That was on there, right? None of your bismuth? Good. All right. Rubidium. Nearest noble gas to rubidium, so he could have an octet, which everybody wants, would be who? Krypton, right there. To become like Krypton, what does he need to do? Lose 1. What would he have for a charge then? +1. You all have that, or 1+, as the book puts it. I know that's technically the correct way to do it, but whatever. Bismuth, what about him? Yeah, now be careful. I bet some people say, well, gee, he's closer to radon. 1, 2, 3. He's going to want to be a -3. He's going to gain 3. No. Remember this line. And again, I will have that periodic table uncovered for tomorrow so you can look up there and see them a little bit easier. Your own periodic table you also have, too. If you see that red line on there, that red line divides the metalloids, the guys from the nonmetals on this side and the metals on this side. These guys are metalloids. All right? Bismuth is not bordering that line. Bismuth is on the left side of that line. What does he do? Loses. So what would his charge be?
+3.
+3? What group is he in? What would you predict his charge to be? +5. He would want to lose 5, right? If he would gain 3, he would be a -3, right? Okay? Y'all got that?
So when they're losing, you look at their group number and then that's
Well, when you're losing or gaining, you're true. You're losing, you look at the group number, and that's the actual number. But in both cases, you're always looking at the group number. Whether you need to gain or lose, you're always looking at that's how many outer shells. Now, these guys in the middle, we're going to worry about them next chapter. They do some funky things, and so do metalloids, and so even does bismuth. But you don't know that yet, so that will be your answer, +5, period. All right, next. What were the next 2 on there?
oxygen and arsenic.
Was oxygen next?
Yeah.
Yeah. All right, oxygen is next.
Yep.
All right, what was oxygen going to be?
-2.
-2, that's pretty easy. Who's next one? Arsenic, that's an easy one, although I bet you some people got it wrong. It's a metalloid. He goes both ways. And here's the mistake you'll make on arsenic. Here's how you know he's a metalloid. He borders that line. He does not, like metalloids. Like you say, well, do all metalloids have to be +4 or -4? No. It turns out the one I did on the notes, I think, was germanium. But this guy can go either way. He'd have to get 1, 2, 3. He'd be a -3 or a +5. Y'all see that?
Yeah.
Because he's in group 5. He could lose 5 or he could gain 3. Anyone bordering the line can do that. All right? Who's next? What was the last one? 10.
10.
Was it 10? I think, right? 10 is not bordering that line. He's on the left side of it. So even though he is in group 4, his charge is not +4 or -4. It's what? +4. Okay? And again, a lot of these guys have multiple charges. Besides that, next chapter we'll talk about some of that. All
So
right.
you're not going to ask us any in group 1 or 2?
Well, sure. I did ask you one in group 1.
What one?
What one did I ask you? One or two?
RB.
Rubidium, yeah. I've asked you other ones in group 1.
Oh, yeah. If they're losing, they lose.
Right.
Gotcha.
All right. Now, several things. We're not done. We have 2 more things to do. Okay, sit. Listen. First of all, on the charts, you can get any of the 4 charts I gave you. You know, it could be atomic size, electronegativity, ionization nature, metallic character. Actually, atomic size and metallic character both look like this, right? They both are going to decrease across a period and increase down a group as you go down a group from top to bottom. You have to know how to read these charts by now. We've seen them almost every day for over a week. All right. What would this chart be?
That would be electronegativity.
Yeah, very good. It's electronegativity because as you go across the period, this guy is increasing. You can see that he's increasing across the period, and he's decreasing as you go down a group. All right? But you know what else does that? Is ionization energy. So how do I know it's not ionization energy?
The accepted.
Yeah, there's ionization energy. These guys have these exceptions. And they're not just random exceptions like there's some funky stuff that goes on over here. You saw that on one of the sheets I gave back to you. This crazy stuff here, that's not like, there's no pattern there. There are some atomic sizes that don't follow the pattern perfectly, but it's not like you see in this. We explain why those exceptions happen, and you should know them for the test. You should read over why they're. I also gave you that sheet back from that worksheet from a while ago that I told you to explain it. What if I asked you this on a question? Who's this pointing to? What would you say? What element is that? He is not chlorine. Beryllium. He is 2 away from number 2. That would be element number 4, atomic number 4, which is beryllium. This is chlorine. All right, because he's 1 away from being 18. That would make him 17. That's the atomic number of 17. That's chlorine. Got it? What if I asked you, what does B correspond to? What would you say?
Period 3.
Period 3. Be careful. Be specific. Remember I said that. All right, the last 2 things I want to talk about here. Remember these? These are the ones that cause you the most trouble in multiple choice format. They're the ones the book asks like this. The book test asks like this. Who would have the highest second ionization? Who would have the highest third ionization energy? And you didn't really know what it meant. And I said to look at your notes about this part of it. Here's how I'll ask the question on the test. I'll have numbers in here. And I'll just say, you don't have to put the numbers in. Your question will say A. Will this be A, an increase, a large increase, a small increase, or a decrease?
A big increase.
This would be a big increase for this guy's ionization energy. Why? Because he'll give up this 1 electron without too much trouble. But the next electron has to come out of an octet, and he's not going to like it. That will be a large increase. What if I said that I asked about that guy right there for magnesium.
It's going to be smaller.
Right. But it's always going to increase. Right. He'll give up one of these, that's right here. He'll give up another one, no big deal. But the third one is where you're going to see the big jump. So you're going to see a big jump here, a big jump there. And of course, you can pretty much tell by what group they're in. This guy will give up 3, and then, so okay, and then bam, he doesn't want to do that. He's going to be a big increase over there. All right. So that's the kind of question you'll get on that. Next. Last thing to summarize, okay? The last summary here I want to make for you is, again, what I've said all along. Everything changes from upper right to lower left. If it's an extreme question, who's the best, who's the worst, who's the highest, who's the lowest, and there's a lot of ways I could ask the question. I want you to listen carefully to what I'm about to say. I'm asking the same question if I say, who's the best nonmetal? Who has the highest electronegativity? Who has the greatest attraction for electrons? Who has the highest ionization energy? I'm asking you the same question. It's always going to be the guy way up here that's attracting electrons, holding on to those electrons the best. The metals, the best metals, guys who lose electrons down here, bottom left. Ignore the guys in the middle for those kind of questions. Makes sense, okay? All right, finally, before you go, or before you come in here tomorrow, you need to do some study. This is probably one of those tests that you're going to study the most for of any test this year, I should say. Most of the time, I have math parts on the review, and I say, okay, if you did well on that, you don't really have to study this. Just study, look over this, that, and the other thing. This test, it's all study. It's all. If you can't, you say, well, I understand the trends now, but you didn't memorize what ionization energy means or electronegativity means. If I ask the question, who's going to lose electrons the best, you can answer it. But if I ask who has the lowest ionization energy, you can't, because you don't know what ionization energy means. So study those terms.